Article 400.13 of the National Electrical Code, or NEC, allows for the use of multiple conductors in parallel for a single circuit, provided the conductors are of the same size and type. Article 408 addresses switchboards and panel boards. Section 408.36 requires that panel boards have an adequate number of overcurrent devices to protect the conductors supplying the panel board. Section 408.38 prohibits installing more than 42 overcurrent devices in a panel board. However, panel boards specifically designed for high-capacity service entrances may have more than 42 overcurrent devices. Article 240 covers overcurrent protection. Section 240.4d states that overcurrent devices must be sized to protect the conductors they supply. Section 240.25 specifies fusing rules for high-capacity services, which require fusing not to exceed 80% of the ampacity of the conductors protected. Considering this information, there does not appear to be any code violation in the described installation. Firstly, 500 kc mil cables are being used in parallel for the three phases of the alternating current units, which is permissible under NEC 400.13. Secondly, the 500 kc mil cables are being fused at 350 amps, which is less than 80% of their ampacity. Thirdly, separate 4/0 cables are being used for the high leg and neutral, which are sized appropriately for the maximum unbalanced load. Fourthly, the 4/0 cable is being fused at 200 amps, which is less than 80% of its ampacity. Fifthly, the panel board is designed for high-capacity service entrances and can accommodate the number of overcurrent devices required. Sixthly, a ground conductor has been provided as required by NEC 250.118. Therefore, the installation appears to be compliant with the NEC. However, it is always advisable to consult with a qualified electrician to ensure that the specific installation meets all applicable code requirements. The use of appropriately sized conductors and overcurrent protection devices is crucial for electrical safety and compliance with the NEC. It is important to carefully consider the load requirements and conductor ampacities to ensure that the electrical system is properly protected from overloads and short circuits. In the described scenario, the installation includes a 400 amp fuse disconnect and a 400 amp panel board with a 120/240 volt delta 3-phase system. The system is primarily intended to power two 10-ton rooftop alternating current units, with the remainder of the panel board dedicated to general-purpose 120/240 volt single-phase loads. The design incorporates parallel 500 kc mil conductors for the phases serving the alternating current units and the single-phase loads, a 4/0 conductor for the high leg and a 4/0 conductor for the neutral. A number 3 THHN conductor is used for grounding. The 500 kc mil conductors are fused at 350 amps, and the 4/0 conductors are fused at 200 amps. Several NEC articles and sections are relevant to this installation. Article 310 addresses conductors for general wiring. Article 215 covers feeders. Article 220 deals with branch circuit, feeder, and service calculations. Article 230 pertains to services. Article 240 focuses on overcurrent protection. Article 250 covers grounding and bonding. Article 300 addresses general wiring methods. Article 408 pertains to switchboards and panel boards. Article 430 addresses motors, motor circuits, and controllers. And Article 440 specifically addresses air conditioning and refrigeration equipment. When determining the appropriate conductor sizes, it's crucial to consider the ampacity of the conductors, as specified in NEC Table 310.15b16, often referred to as the ampacity table. This table provides the allowable ampacities for insulated conductors rated up to and including 2000 volts, based on the conductor material, insulation type, and installation conditions. The 500 kc mil conductors, depending on their insulation type, have an ampacity ranging from 380 to 430 amps. The 4/0 conductors have an ampacity ranging from 230 to 260 amps, again depending on the insulation type. The number 3THN conductor has an ampacity of 100 amps. The overcurrent protection devices, such as fuses or circuit breakers, must be sized to protect the conductors in accordance with NEC 240.4D. This section generally requires that overcurrent devices be selected based on the conductor ampacity. However, there are exceptions for specific situations, such as motor circuits, where the overcurrent protection may be sized higher to accommodate the motor's starting current. In the described installation, the 500 kc mil conductors are fused at 350 amps, which is below their ampacity. The 4/0 conductors are fused at 200 amps, which is also below their ampacity. This approach helps ensure that the conductors are adequately protected from overloads. The neutral conductor must be sized to carry the maximum unbalanced load, as determined by NEC 220.61. In this case, the maximum unbalanced load is 200 amps, and the 4/0 neutral conductor is sized to handle this load. The grounding conductor must be sized in accordance with NEC 250.122, based on the size of the overcurrent protection device. For a 400 amp overcurrent protection device, the grounding conductor must be at least a number 3 AWG copper conductor. The installation also involves the use of a high leg, which is a characteristic of 120/240 volt delta 3-phase systems. The high leg is the phase with a higher voltage to ground, typically around 208 volts. NEC 110.15 requires that the high leg be identified by an orange color. In this installation, the high leg is used to supply the two alternating current units. NEC 440.22b provides specific requirements for the location of disconnecting means for air conditioning and refrigeration equipment. This section requires that a disconnecting means be located within sight from and readily accessible from the equipment. The panel board must comply with NEC 408.36, which requires that it have an adequate number of overcurrent devices to protect the branch circuits. It must also comply with NEC 408.30a, which limits the number of overcurrent devices in a panel board to 42, unless the panel board is specifically designed for high-capacity service entrances. The installation must also comply with NEC 300.3b, which requires that all conductors of a circuit be contained in the same raceway or cable. This helps to minimize inductive reactance and voltage drop. In summary, the installation appears to be code compliant, provided that all NEC requirements for conductor sizing, overcurrent protection, grounding, and equipment installation are met. However, it's always essential to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable codes and standards. Furthermore, any specific requirements or interpretations by the local authority having jurisdiction must be considered. This analysis is based on the information provided and the understanding of relevant NEC provisions. It's important to consult the latest edition of the NEC and any applicable local codes for the most accurate and up-to-date information. Always prioritize safety and compliance with all applicable codes and standards when performing electrical work. In addition, it is important to consider the voltage drop in the conductors, especially over a long distance like 150 feet. NEC 215.2 AM provides recommendations for voltage drop in feeder conductors. It recommends that the voltage drop should not exceed 3% for power, heating, and lighting loads, or 5% for feeders. To calculate the voltage drop, you can use the following formula: voltage drop equals 2xkxixt/cm, where k is the constant for the conductor material, 12.9 for copper, I is the current in amps, d is the one-way distance in feet, and cm is the circular mils of the conductor. For the 500 kc mil conductors, the circular mils is 500,000. For the 4/0 conductors, the circular mils is 211,600. By calculating the voltage drop, you can ensure that the conductors are sized appropriately to minimize voltage drop and maintain adequate voltage at the load. Another important consideration is the short circuit current rating of the panel board and the overcurrent protection devices. The panel board and overcurrent protection devices must be able to withstand the available short circuit current at point of installation. This is specified in NEC 110.9 and 110.10. To determine the available short circuit current, you can perform a short circuit study or consult with a qualified electrical engineer. If the available short circuit current exceeds the short circuit current rating of the panel board or overcurrent protection devices, you may need to use current limiting fuses or other means to reduce the short circuit current. It is also important to consider the ambient temperature and dating factors for the conductors. NEC 310.15b2 provides dating factors for conductors installed in high ambient temperatures. If the ambient temperature is higher than 30 degrees Celsius, you may need to direct the ampacity of the conductors. Additionally, NEC 310.15b3 provides dating factors for conductors installed in raceways or cables with more than 3 current-carrying conductors. If there are more than 3 current-carrying conductors in a raceway or cable, you may need to direct the ampacity of the conductors. These dating factors help to ensure that the conductors do not overheat and cause a fire. The installation also includes 2 10-ton rooftop alternating current units. NEC 440 provides specific requirements for air conditioning and refrigeration equipment. NEC 440.6 provides requirements for the ampacity rating of the conductors. The conductors must have an ampacity equal to or greater than the sum of the rated load currents plus 25% of the largest motor compressor rated load current. NEC 440.12 provides requirements for the motor compressor overcurrent protection. The overcurrent protection device must be capable of carrying the starting current of the motor compressor. NEC 440.22 provides requirements for the disconnecting means. A disconnecting means must be located within sight from and readily accessible from the air conditioning or refrigeration equipment. In addition to the NEC requirements, it is important to consider any applicable local codes and standards. Local codes may have additional requirements that are not covered in the NEC. It is also important to follow any manufacturer's instructions for the installation of the equipment. By following all applicable codes, standards, and manufacturer's instructions, you can help to ensure a safe and reliable electrical installation. Remember to always work safely and consult with a qualified electrician or electrical inspector if you have any questions. In the described scenario, the installation includes a 400 amp fuse disconnect and a 400 amp panel board with a 120/240 volt delta 3-phase system. The system is primarily intended to power 2 10-ton rooftop alternating current units, with the remainder of the panel board dedicated to general-purpose 120/240 volt single-phase loads. The design incorporates parallel 500 kc mil conductors for the phases serving the alternating current units and the single-phase loads, a 4/0 conductor for the high leg, and a 4/0 conductor for the neutral. A number 3 THHN conductor is used for grounding. The 500 kc mil conductors are fused at 350 amps, and the 4/0 conductors are fused at 200 amps. It appears the installation is code compliant provided all NEC requirements for conductor sizing, overcurrent protection, grounding, and equipment installation are met. Always consult with a qualified electrician or electrical inspector to ensure the installation meets all applicable codes and standards, and consider any specific requirements or interpretations by the local authority having jurisdiction. Prioritize safety and compliance with all applicable codes and standards when performing electrical work.